Hello, calculus fans. Let's talk about planes. Now, a line in space can be described with a point and a direction parallel to the line. We've done a few problems involving that now. Plane cannot be similarly defined. So if you take a vector that's parallel to a plane, that's not enough to describe the direction of the plane. However, if we take a vector orthogonal to the plane, that does completely specify its direction. So a plane in space is determined by two things: a point, P0, on the plane, and a vector n that is orthogonal to the plane. So this orthogonal vector n is called a normal vector. Now let's let P be some arbitrary point on the plane. It has coordinates x, y, z. Let's let r0 and r be the position vectors of P0 and P, respectively. Then we can say that r minus r0 is the vector P0, P. Here's a picture of what's going on. So P0 and P are points in the plane. The vector P0, P lies in the plane and is orthogonal to the vector n. So n is an orthogonal vector to the plane. Any vector that we create that's in the plane will be orthogonal to n. N is our normal vector to the plane. So the normal vector n is orthogonal to every vector in the plane. And notice that it is orthogonal to r minus r0 because that's a vector in the plane. And therefore, what we can write is that n dotted with r minus r0 is equal to 0. Remember, the two vectors are orthogonal if and only if their dot product is 0. Now in this equation, n and r0 are fixed quantities. R is the thing that's allowed to vary, and that will vary and describe all the points in the plane. This is called a vector equation of the plane. Let's write down a scalar equation for the plane. So n is going to be the vector ABC, that's a fixed vector. And r is going to be the variable vector x, y, z. And then r0 is x0, y0, z0, also a fixed vector. Now let's take the vector equation that we wrote down and see what it turns into. So n dotted with r minus r0 is equal to 0. Do the vector subtraction, we get x minus x0, y minus y0, z minus z0, and that gets dotted with ABC. And then if we perform the dot product, then we get a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. This is called the scalar equation of the plane through the point P0 with normal vector n. P0 has coordinates x0, y0, z0. N has components a, b, c. We are going to use this equation quite a lot in this class, so you want to be familiar with that. Okay, that's all for now.